Hello everyone. Today we're going to be talking about how to manipulate trig identities. Here I have some Pythagorean identities. Now this one I've already shown, and these are just manipulations of this first one. So if we take this first one and we go ahead and divide by sine squared, like so, okay, then what we end up with is this becomes 1, this becomes cotangent, and this becomes cosecant. So that gives us this one here when we divide by sine. So that becomes 1, that becomes cotangent squared, that becomes cosecant squared. Likewise, if I take these and I divide by cosine squared, then this becomes tangent squared, this becomes 1, and this becomes secant squared, and that gives us this one. So really, all three of these are just variations on each other. Right? This is the original one, and then these two are just different variations on this one. Now, you can use these to manipulate some expressions, and we're going to show that now. So for example, let's say you have tangent of x over secant of x. Now this looks more complicated than it needs to be. So one thing we can do is we can write this as tangent being sine over cosine divided by, and then secant is 1 over cosine. Right, so sine of x over cosine of x divided by 1 over cosine of x. Now because both the numerator and the denominator are being divided by this cosine of x, we can factor that out, that divides out, and we just get sine of x over 1, which is just sine of x. Okay. Using the Pythagorean identity, we can manipulate this as well. So cosecant squared of x minus 1. Now if we go back up here, right, see we see cosecant squared of x. Now this expression doesn't really appear here, but what we can do is if we subtract 1 from both sides over here, we get that cotangent squared of x equals cosecant, cotangent squared of x equals cosecant squared of x minus 1. And that's by subtracting 1 from both sides of the equation. So we see here that cosecant squared of x minus 1 equals cotangent squared of x. So that means here's cosecant squared of x minus 1. This is cotangent squared of x. So this is tangent of x times cotangent squared of x. Now tangent of x and cotangent of x are reciprocal functions of each other. They're reciprocals. So this is cotangent squared of x is really just 1 over tangent. So what we really have is we have tangent of x divided by tangent of x squared, or tangent squared of x. Now because we have one instance of tangent of x in the numerator and 2 instances of tangent of x in the denominator, we can divide out one of each. We can factor out one of each. And that's going to give us 1 over tangent of x, or you can just call that cotangent of x. So we manipulated this, and we realized that that is really just cotangent of x. Now, coming over to here, if we see something like this, right, kind of messy, we can actually, by multiplying these, we will get some expressions that will end up being reducible and simplifiable. So for instance, one thing I can do is I can multiply here these two functions, or sorry, these two expressions, and we'll get 1 plus secant of x minus cosine of x, and then plus or minus 1, sorry. So then this times cosine of x. Okay, well, before we multiply cosine of x in, I noticed that I have a 1 minus 1 in here, so this is really just secant of x secant of x minus cosine of x times cosine of x. So we can distribute this, secant of x times cosine of x. These are reciprocal functions. So that means when we multiply cosine of x times secant of x, we get 1. And then cosine of x times itself is just cosine squared of x. Now, 1 minus cosine squared of x, if we go over here, if we subtract cosine squared of x from both sides, we'll get that sine squared equals 1 minus cosine squared of x. So 1 minus cosine squared of x is sine squared of x. So this is actually sine squared of x. So you can see how these Pythagorean identities are really powerful. Sometimes we have to adjust them and kind of move things around, but we can use that to replace and to simplify where we would have maybe two trigonometric expressions, two trigonometric terms. We can simplify them, and sometimes we can get down to one trigonometric term. Or if you have some kind of expression like this, we can simplify it down so it's just a trigonometric function. Okay, so let's go over here. We have here secant squared of x minus 1 divided by secant of x minus 1. So we can use the difference of squares here, secant squared of x minus 1, to factor along the top, and that'll give us secant of x minus 1 times secant of x plus 1 divided by secant of x minus 1. And what we can do is we can cross these out. Another thing we can do is, if you have secant squared of x minus 1, we can see that that's actually equal to tangent squared of x. Right, so what we have here is we actually have tangent squared of x over secant of x minus 1. So a couple of different things you can do there. Now over here, this comes into play a lot when you want to solve. If you're trying to solve an equation, like let's say that this equals 0, right? If we know how to factor these and manipulate them, we can actually solve equations like this using the zero product property. So over here, we can actually factor cosine out of both of these, and we get cosine of x times 1 minus sine squared of x. Now, cosine of x times 1 minus sine squared of x, we know that 1 minus sine squared of x is actually cosine of x squared. So what we really have here is cosine of x times cosine squared of x, which is just cosine cubed of x. So all these different manipulations, right, you have to be comfortable with doing them all. Here's another manipulation that we can do. We have secant of x minus cosine of x over secant of x. Well, we can actually split this up into secant of x over secant of x minus cosine of x over secant of x. Okay, secant of x over secant of x, that's just 1. Cosine of x divided by secant of x, that's cosine of x divided by 1 over cosine of x. In other words, this is really just cosine squared of x. Okay, and then 1 minus cosine squared of x, that's just sine squared of x. So we went from having this mess all the way to sine squared of x. That's very useful because we're taking what is effectively 3 different terms, 3 different areas of a expression that each could be interacting in different ways, and we're turning it into one. Now over here we have sine of x plus cosine of x times cotangent of x here. So cotangent of x is just cosine over sine. So what we have is we have sine of x plus cosine squared of x over sine of x. Now, if we get a common denominator here, we can actually, for instance, take this sine of x on the left and multiply its. We can create a denominator for it and multiply the numerator and the denominator by sine of x, and then these two will be fractions that have common denominators, rational expressions that have common denominators. So multiply this and this, right, numerator denominator by sine of x, we get sine squared of x over sine of x. And now because they're going to have a common denominator, we can put it just over one big denominator, and we can say that that's sine squared of x plus cosine squared of x divided by sine of x. Okay, and we know sine squared of x plus cosine squared of x is 1 because that's what this says right here. So this is 1. We get this to be 1 over sine of x, which is really just cosecant of x. So we went from having this to just cosecant of x. Now you can just mess around with this and do all kinds of different things. With this one, right, cosine of x over 1 plus sine of x, we can multiply this, the numerator and the denominator, by 1 minus sine of x, like a conjugate pair. Okay, and that's going to give us 1 minus sine of x times cosine of x. And this will be 1 minus sine squared of x, which we know is cosine squared of x, plus tangent of x. Now here we've got cosine squared of x over under cosine of x, so we can actually end up dividing these. And we get 1 minus sine of x over cosine of x plus tangent of x. We can split this part up into two different rational expressions. And that's going to give us 1 over cosine of x, which is just secant of x, minus sine over cosine is just tangent of x, plus tangent of x. Well, we have minus tangent of x plus tangent of x, so these guys go away. And all we have is 1 over cosine of x, which is really just secant of x. So we went from having all of this to over here. Anyway, I hope that helps. And have a great rest of your day.